Perfect. Thank you, James. Thank you very much. I am Luke Pollard from BASF Digital Farming. And as James said, Dr. John Redhead from UKCEH will be joining us a bit later on to share a few slides. So in this session, we're going to be talking about how sustainable crop production practices can be aided by digital farming. So just to give you an overview of what we'll cover here, we'll look at how field management decisions can be supported by digital agronomic models. We can look at how farmers can use digital farming techniques and technologies to help them implement environmental measures for their crop production. And also, I'm going to share a success story around collaboration between Exarvio and the UK Centre for Ecology and Hydrology. So to jump straight in, so to share a bit about who Xarvio Digital Farming Solutions are and what we do. So we're the digital arm of BASF, and we have a presence globally with our different products. So Xarvio Scouting, Xarvio Field Manager, and Xarvio Healthy Fields. And we have a strong and growing presence in Europe. So our purpose is to develop digital farming solutions that can help growers and agronomists to improve and automate crop production by providing agronomic insights for crops that have been grown and data-driven crop models to assist with decision making on farm. And our aim is to equip growers with tools to help them use crop inputs only when and where they are needed. So now, considering the wider BASF company, sustainability is a key element of the corporate strategy, and it has been going back decades. And we know that there are demands and expectations made of agriculture and of growers today, and BASF aren't shying away from these. So we believe that finding the right balance is essential to ensure that we continue to feed a growing population and to enhance the management of the natural environment and make the best use and justify the use of the resources that we have available. So we see digital technologies as a key enabler for us all to achieve a more sustainable agriculture. So to focus on this session, we're going to be looking at the Xarvio Field Manager system, and this assists growers with sustainable production of their crops. Field Manager is a digital solution where growers can document their fields and crops that have been grown on the system, and then as a result of that, they receive a host of agronomic insights to help them with their crop production decisions. Field Manager was launched in Great Britain at the start of 2020, and that means that growers this season will be moving in to their third season of using the system as they drill their crops this autumn. So in 2021, Field Manager has been used on over 3,000 farms in Great Britain. And you can see on that slide there, it's actually been used more across Europe. It's been used on over 50,000 farms. So this is just a brief overview of just some of the features available to growers from the Xarvio Field Manager system. Field Manager differs from other digital farming tools available on the market today, as it has features that will help growers with their crop production right from the start of the season when they first drill their crops, right the way through the season up to the harvesting of their crops. And now to focus on two features within Field Manager that are particularly relevant to the topic of today's session here, and that's sustainability. So firstly, I wanted to talk about the spray timer feature. And this is a feature which provides growers with field-specific alerts for the most efficient application timing for their crops, application timing for fertilizer, for crop protection. And this is based on agronomic crop modeling, which looks at the field-specific situation by analyzing data and information that the user has put in about their field. So for example, looking at what crop was drilled in that field. Was it wheat, barley, or oilseed rape? What variety was drilled? so the agronomic modelling can understand the nuances of that variety. Also looking at the weather information, also looking at the weather that the crop has experienced up to that point and will experience with the predicted weather. Also, the crop models will take into consideration any applications that have already been made to that crop up to that point in the season. So Spraytimer is also providing to the user, to the grower, insights such as crop development and growth forecasting for the crops, and also an overview of disease and pest risk. And this risk indicates when a crop is more likely to be susceptible to a disease or a pest, based on all of this information that the agronomic models is analyzing. So in summary, the Spraytimer feature provides data-driven information to growers to give them the confidence to apply crop protection products and fertilizer in the most sustainable way, with an approach that's based on their field-specific conditions, their field-specific weather conditions, and also the pressure that's currently on their crop. So moving on to the next slide, the zone spray feature complements Spraytimer. So zone spray helps growers to apply the optimal amount of input to their crop for each part of their field by utilizing variable application technology. So Field Manager looks at satellite imagery for each of the fields to determine which areas of the fields are growing more successfully and which areas less successfully. So the growers' fields in the system are being looked at by Field Manager and split up into different zones of least successful, most successful growing areas. So the grower can then decide if they would like to adjust the amount of input they apply across these different areas of their field, instead of applying it at the same rate or the flat rate across the field. So if they do choose to apply variably, they can create a variable application map within Field Manager, which they can then use with their farm machinery. So for example, looking at a fungicide application in the spring, a grower could decide to reallocate their fungicide so that they apply a bit more where their crop has been growing better and it has more green leaf area to cover, and apply a bit less where the crop is thinner and it hasn't grown so well for whatever reason. So you can see here how if a grower uses both Spraytimer and zone spray together, it means that the grower can apply their farm inputs like fertilizer or crop protection in the most sustainable and effective way, applying them at the optimal time and tailored to exactly where they're needed in that field. So now to take a bit of a sidestep and just talk about the partnering that we do with Azavio and BSF Digital Farming. So a key focus for us is providing greater efficiency, convenience and outcomes for growers, helping them to optimize their crop production and make the most of their land. So to achieve this, we believe that exploring and establishing partnerships is essential in the digital farming environment, and this is something we're always open to doing. A great and recent success, an example that I wanted to share with you, is a partnership between Xarvio and the UK Centre for Ecology and Hydrology in Great Britain. So we've joined forces this year with UK CEH to integrate their detailed environmental data from their Assist ePlanner tool with Xarvio Field Manager. So as a result, this means that growers and other users of Field Manager are now able to accurately identify less productive areas of their fields and then assess the suitability of these areas for a range of environmental management options. And as a result, they can then create management zones within Field Manager, and they can integrate these management options and management zones with their application maps or their seeding map, their fertilizer map, their crop protection maps, which they use in their farm machinery. So this allows growers and other stakeholders who are using Field Manager to make better, more informed decisions around their field use. And we're looking to help to ensure that where land managers do choose to incorporate environmental management options into their fields, that they're put in the best place and that they do deliver. So now I'm going to hand over to Dr. John Redhead from UKCEH, who's going to give a bit more of a background, understanding and information about these biodiversity layers.
Great, thanks very much, Luke. Hi everyone, I'm John Redhead from UK Centre for Ecology and Hydrology, and I'll just take you through a bit of the background of the biodiversity layers that have gone into Xavio recently. Can you move on to the next slide, Luke? So UK Centre for Ecology and Hydrology are an independent, not-for-profit environmental research organisation, and we've been working on sustainable agriculture in general and things like the design and monitoring of agri-environment schemes for at least 20 years now. So we've got a really good understanding of what works well on farm and what management actions are likely to deliver the best possible environmental outcome. We work closely with the UK farming sector to make sure that the solutions we come up with are not just sustainable from an environmental point of view, but also from the farmer's point of view in terms of having a viable, practical farm business. So we've got this understanding of what works well where, and we also have evidence that putting that information in the hands of farmers in an easy to use way significantly improves their success in delivering environmental benefits. Next slide. So as Luke's pointed out, there's an awareness now that farmland needs to deliver a wide range of environmental benefits as well as its traditional role in producing food. And sustainable agriculture implies getting this balance right between farming for food on the one hand and farming for nature on the other. And we're increasingly well used to seeing a really wide range of data sets and tools that offer support to the agronomic side of things, decision making. But so far, there's been a lack of tools and data at these kind of fine spatial resolution to subfield scale to support environmental decision making. And that's the gap that we aim to fill with our ePlanner tool. On to the next slide. So ePlanner was developed under the ASSIST project, Achieving Sustainable Agricultural Systems, and it's a simple map-based tool that presents the relative suitability of farmland for different environmental management options. It's free and it works equally well on your desktop or your mobile via the web, and it's got full coverage of all agricultural land in Great Britain. And its core aim is to streamline and support farm environmental planning by putting environmental data in the hands of farmers. Next slide. So the way that it works is it accesses a whole range of national scale environmental data sets. So for example, if you were planning to grow some wildflower habitat for pollinators, you'd ideally choose these south-facing slopes where those flowers are going to grow well and where the bees like to forage because it's warm. You'd avoid deep shade. You'd avoid areas that lie wet. You'd ideally put it near existing good pollinator habitat rather than creating little isolated islands. And you'd choose lighter soils over heavy ones because that's where the wildflowers tend to grow well and where solitary bees build their burrows. So by stacking all of these layers up, we can create a suitability map for that particular environmental option. Just go to the next slide. So you can see on this map here, we've got the areas that range from green areas, the most suitable, where lots of these criteria are met, to the pink and white areas where very few of these are met. And we can create all of these maps at 5-meter resolution, so these fine scales that you're used to seeing from precision agricultural data. Next slide. Yeah, so we've created these maps of suitability for 5 different environmental options: pollinator habitat, water resource protection, sown and winter bird food, woodland creation, and wet grass and restoration. And these aren't prescriptive, so pollinator habitat might be creating pollen and nectar mixes on arable land, or it might be the restoration of species-rich grassland. So they're sort of clusters of environmental opportunities. And these suitability maps are what have been streamed into the Xavio platform this year. Next slide. And the way these work is that you can see these suitability maps. So if you have a particular area in mind, you've used your precision agricultural data to say, well, this areas are consistently underperforming and I want to take it out of production, do something environmental with it. You can use the maps to explore, well, which environmental option is going to be most suited to that area. Or you can actually turn the question on its head and say, I've got a particular environmental option in mind. I want to create some woodland on my farm, for example. Where are the areas that that woodland is most likely to deliver the environmental opportunities it has potential for? Next slide. So we've worked quite hard when we've been building this tool to validate it and to make sure it works and is easy to use. And we've done some independent validation where we had experts go out into the field on 2 large farm estates and compare the scores from the ePlanner maps with their own judgment on the suitability of the land for creating different environmental options. And you can see from the graph on the top right there that actually the scores from ePlanner and the independent expert assessments line up really nicely. And we've also had a lot of positive feedback from other farmers in how helpful ePlanner has been in supporting their environmental decision making. And in many cases, it gives farmers confidence in backing up decisions they've already made. So if you just go on to the next slide, Luke. Yeah, so this farmer had already created a really successful wild bird food option, and we were able to confirm with the ePlanner map that that was in a place that was marked as really suitable for that and suggest other locations on the farm that might deliver equally well. Next slide. So in terms of why we've partnered up with Xavio, well, as environmental scientists, we're really keen that our research findings actually make it out into the real world and influence people's decisions on the ground. So connecting up to a trusted and sort of cutting edge platform that farmers are already using, like Xavio, just really enhances our ability to make sure our research makes it out into the real world and is put into practice. It also has the advantage that it brings the agronomic side of that balance and the environmental side into the same integrated platform and workflow. So rather than having to have separate tools for both, you can in fact see your environmental data and your agronomic data in the same place, which is going to massively increase how useful that is to the farmer. I'll hand you back to Luke. Thanks very much.
Thank you, John. Thank you very much. That was really, really interesting stuff. John just spoke there about the benefits of bringing these different bits of data into the same workflow. So what I want to do now is actually just share with you a quick video of how these biodiversity layers look within the Xavio Field Manager system and how users of Field Manager can utilize them. So firstly, for a user to access these data layers, they come onto the Xavio Field Manager system, they go onto the status page of their field, and they go to the Management Zones tab. From here, they can overlay different data layers, such as the Power Zone map from Xavio, which is a historic productivity map of the field, showing historically where in the field has performed better and where worse, with the light green areas being where it's been less productive. Just like you've seen there, you can overlay now the biodiversity layers from UKCEH, and then you can see, for example, as a pollinator habitat, where is most suitable on that field, and we can see that in the dark green area. So what a grower can then do is adjust these maps, turn them off, turn them on, adjust the transparency to try and understand exactly where in the field you have a less productive area and where that overlays with an area that's most suitable for a biodiversity measure, such as a pollinator habitat. And once a grower's decided and they're looking to have an alternative land use on that field, they can then draw a management zone around an area in that field. They can then save that management zone, give it a name, give it a category. So you might be categorizing it as a biodiversity zone, as we do in this example. And then also you can set whether it's a permanent feature or just a seasonal feature. So then from that point, when a user then wants to create an application map within Xavio Field Manager, they can easily incorporate the management zone into an application map. And so it's excluded from the application map, in this case, a seeding map, but it could be for fertilizer or crop protection. So then once a user saved the application map with the management zone already excluded, they can then export and download that application map from Xavio Field Manager, which they can then take to their farm machinery for use in their terminal. So once they've done that, they can make an application on their field, and that management zone, that biodiversity plot, will be automatically excluded. So that brings us to the end of our presentation. So thank you all very much for your attention, and we'll hand back over to James to pass comments. Thank you.
Thank you very much, Luke and John, for that very interesting presentation. As we wait for the questions and comments to come into the Q&A, I'll take my prerogative as moderator to ask a question. For the ePlanner or Zavio, the field manager, can the farmer take into account the size and capacity of his equipment in determining those field areas? For instance, if he has a certain size of equipment or a certain type of equipment, some field, some area shapes just wouldn't work, or some would work better. Can that be taken into account?
John, firstly, yeah, I'll take that. Thanks for the question, James. In specific terms on the Zavio Field Manager system, not currently. There isn't a feature there to enter the boom width, for example.
Right.
But what I do know is how a sprayer will be reading the application maps on the terminal. It will be looking to split out the application map across the boom and actually create a bit of an average. So if it's falling halfway through the boom, it will go where the majority of the prescription is, if that makes sense. Not sure if you have anything to add there, John.
Is one of the places that environmental options usually end up, or historically have ended up, tended to be in sort of awkward corners where you had machinery turning issues. Mm-hmm. So although ePlan doesn't specifically take account of that, what it does allow you to do is look at whether those awkward field corners are in fact the best places to put environmental options, or whether actually there are other alternatives to that.
Okay, thank you. There's a question that's come in on the Q&A. What is the cost of the software to the farmer on a per hectare basis?
Great. No, that's a great question, and obviously one that people will be interested in. So just to say, the Zavio Field Manager system, if you want to look at the pricing, it's available online. Just go to zavio.com, click on the pricing tab, it's all there. It's actually charged at a per farm basis currently. And if you wanted to give all of the functionality and features that I've just spoken about, you can actually test all of that on two of your fields for completely free. So there's kind of that first step. You can set up all these things on 2 fields on your farm, test everything I've just been speaking about completely for free. And then if you wanted to ramp that up in a following season, for example, over more fields, if you were just looking at doing some variable rate application across more fields, then that's around £200 per farm per year. And then if you were looking at also adding in the agronomic modeling that I spoke about, the growth stage modeling, and also the pest and disease risks and the alert for the optimal application timing, that then goes up to £500 per farm per year. Like, you can get a lot more detail on what the different price structures include by looking at the websites.
Thank you.
I'll just add that ePlanner as a standalone tool is totally free, so you can go onto the ePlanner website and use that. But of course, you don't have the benefit of seeing that directly alongside your agronomic data.